Good morning. In this video, we will talk about if you are using on-prem data warehouse like SQL Server, how you can modernize your data warehouse using Microsoft Azure Data Lake and Azure Databricks. Also, we will have a live demo which will go through a use case with one of the scenarios. So why do we modernize? We modernize first and foremost because there has been an evolution with the database systems. Back in the 80s, 90s, we have been using line of business, CRM, and ERP applications. And progressively, it's more and more the case where we are dealing with a wide range of data, huge varieties, and various velocities. As well, you may have heard the talk about zettabytes of data. Now the relational side will take a percentage of that, but more and more of that is unstructured. As business, we have to find out a way to get value from that. This is where modern data warehouse fits in um, over these kind of scenarios, and you need something like Azure Data Lake, Data Factory, Databricks to help you with that. So let's talk briefly about the evolving world of analytics. So we started with the descriptive analytics where we load data in data warehouse to provide historical data. Uh, it, it's like looking back in rear view mirror of your car that what happened, right? And then we move to diagnostic data. You ask the question, why did it happen? And the most common tool we use it is Microsoft Excel. Then predictive and prescriptive is basically analyzing the current and historical facts to make future predictions. Then the final thing where everybody wants to be is the cognitive, where you ask a chatbot that you ask a chatbot a question, and then based on the previous transaction and history stored in the data lake, it is giving you the right answer. This is how the Azure big data landscape looks like. So on the left, you have the ingestion services, the storage, the Azure Databricks where you do the preparation, and then ML, the modeling piece, and the visualization piece. This is a typical data warehouse housing pattern in Azure. So you have both your unstructured file and also structured files, and then like using Data Factory, you basically ingest that in your data lake, or you can also, and if you have line of business transaction data, that also goes with the data lake. Then you do the data preparation using something like your Databricks, and then model that data in any of these services available out here, and then visualize it using Power BI. We have seen massive adoption of this architecture in the following verticals: financial, retail, automotive, and IoT, advertising and marketing, health and sciences, entertainment media, security, and industrial IoT. Let's take a few examples to see how the modern data architecture is being used in these verticals. In the financial industry, it has been used to do customer analytics by looking at the customer profile, credit history, transactional data to derive a customer 360 module and to do customer segmentation, reduce customer churn, and also insight for new products. In the industrial IoT world, it is used to do supply chain optimization. So by looking at the transaction data, demographic, purchasing history trend to derive trade monitoring, optimization, retail mobile applications, vendor management, and truck and delivery optimization. Now let's go through a live demo of this solution architecture.
Hi everyone. Today we are going to have a look at ETL pipelines for Azure Data Lake. For this particular demo, we have used Delta Lake from Databricks, and let's just get started. Okay, so just a brief overview before we begin. Um, when it comes to big data processing and data lakes using Databricks actually provides a Spark-based environment which serves as the unified data platform. It can do both your data engineering and data science for your team. So, and in terms of ETL, you can use Databricks Spark instances for processing all historical raw data or get any new data from streaming services like event hubs or from your SQL tables. And you can also keep track of all your changes. And all of this can actually be written to a single delta table, which is then later optimized and then can be queried. Okay, so and there is a second architecture that can also be used with your Delta Lakes, and it uses the same premise as the previous architecture. So you can have all of your streaming and batch files, and you can have the ingestion tables, which is your bronze Delta tables, and you can have your refined tables, which are semi-processed but uh, are still not completely updated as per your BI or data science needs, which is your silver region. And there is a gold region, which is completely processed and fully ready data, which is ready for pushing for your analytics and machine learning. Okay. Okay. So for the current demo, we have used the dataset that's available at Lending Club, and we can. This is basically a data set for all of the loans that have been taken from Lending Club, and it contains labels for whether a loan has defaulted or not, or whether it's been paid in full or not, and how long these loans are to last. And initially, what we'll do is that we'll just load all of this data in a CSV format, and we'll create Parquet tables out of it. So since we are using Spark, we can basically use the DB utils file system to to read all of our data and convert it into Parquet format, and we can then move ahead for to with our ETL. So basically, we just use Spark's read function to get all of the data that we need, and we only select the columns that we need for this ETL process. Right. And once all of this is selected, we create a temporary view for us to view what has been selected and what, and we can do some exploratory data analysis with it. Okay, so once we have loaded our data in a Parquet format, we can convert it into Delta files, which would be part of our Delta Lake now. So uh, we can see that we can make use of plain SQL for this, or we can use Spark DF commands. And basically, to just convert uh, our Parquet files to Delta files, we just need to rewrite them in a different format. Okay, and once our Delta tables have been created, we can actually create a transaction log for all of the tables, and we can see that a new set of files has been generated, one being the delta log, which keeps track of all of the delta files that are being created and all of their metadata. And then we have snappy Parquet files, which are stored in the uh, Deltabricks file system. The great thing about Delta Lakes is that you can actually use plain SQL on top of your Delta files, and it will function just as fine. This is quite an interesting thing because currently a lot of data engineers still rely on SQL based queries. So this takes out the time and effort that is needed to train new resources. Instead, you can use your own resources when you go ahead to modernize your data warehouses. The second thing about Delta Lake is that it provides a full DML support as well. So you can update your tables, you can delete them, you can merge them, and basically these would all just be Delta files that would be treated as tables by the Delta Lake platform. And another beautiful thing about this is that since we are using the Databricks environment and Spark with it, we can actually visualize all of the data that we are generating. And this would actually be quite beneficial for a lot of data engineers and BI analysts who are trying to get insight or trying to do some exploratory data analysis with the data. So let us look at what do we mean by full DML support. Suppose that the data for Ohio was not input correctly and it had to be originally assigned to IA. So we would need to like delete all of the values on OH and would replace it with a new set of values. So for Delta Lakes, it's no different like what you would want to do with plain SQL. You'll just need to identify which file you want to remove it from and on which attribute you want to remove it. And we can like validate that data, and you can see that now the state of Ohio does not have any more data available, whereas previously this data was available. It's the same with the update. So, for example, if we wanted to upgrade some of our loans from of grade G to be updated to a grade Z. So, let us first visualize all of the loans that we have currently, and we can like just select all of these loans and generate a small bar chart for that. And we can see that we have loans G, but we don't have any loans of the value Z. So if we update this and we move all of these loans G to a grade Z, we'll just need to run the SQL command for update loans and just set the grade value. So, and when we visualize this again, we can see that now G has gone and it's replaced by grade Z. So basically, even if you modernize your data warehouses with by replacing them with the more flexible data lake built on top of Delta lakes built on top of data lakes, it won't make a huge difference for you in terms of training your resources or replacing them, because they can still utilize the things they had learned and they utilize for data warehousing, but the approach would now be much more flexible and can accommodate more types of data sources and can give you better insights as well.